Hi there, how you doing? Yeah, I know, another electronic video, but it's getting hot outside again. The last few days hasn't been too good. So I don't have too much going on. I got the cabinet over here on the floor inside. The mustiness on that tube tester case is just about gone. Now I went to my local hardware store to get a small can of shellac. A little tiny can. It wants $7.50 for it. He jokingly says, yeah, I asked him for shellac. He says, yeah, I'll give you a shellac. And he says, they're fun guys over there, but you know what? They're very expensive. So, I'm not paying $7.50 for a small can of shellac. I mean, the smallest can you can get, you know what I mean? So, I think it's all right. It's sitting on the floor here. I'll show you. And I don't even smell it now. And I think this came out really good. You really can't notice it. There's a slight texture difference here. Oh, I'm happy with it. So, I'll keep that down here. The tube tester, all the resistors with the exception of, I think, 2, were all out of specs, all increased in value because of carbon comp. I need a 470 ohm 1% resistor, which I don't have, and a 51 ohm 1%, and I think one other one. So that's on hold right now. I've been looking on eBay because that's why I buy my stuff. So much easier to use, as I said so many times before. But this video is not about the tube tester at this time. I want to make a video on this meter here. The military meter, signal core model TS-297/U. Multimeter that I paid $5 for at the Jewett City Flea Market last week. So let me take you up to the bench right now. But before I do, one of my viewers had to look back on the comments, as I'm getting way behind on the comments. There is no zero adjustment on here. There is none. One of my viewers told me there is no adjustment. I looked all over this thing. Now, there are 3 screws. I'll get you a close-up. There are 3 screws here. Now, this comes out very easily, and I'll even open it up for you on the bench, with 4 screws, machine screws. Comes out very easily. There is a place for a C-cell, but I didn't have a C-cell battery. So I set my power supply up here to 1.5 volts. And I put a digital meter on it, even though this dial here is accurate, this meter here. Set it for 1.5 volts exactly. And this meter is way off. But I will show you. I'll take it apart and show you. There are 3 screws here, but there are nuts and washers on the inside. And this one here you can get at very easily and get at the nut. The other 2, they're underneath in a position under the circuit board, and it's a nightmare trying to get it out. Everything that's made either by Tektronix, this wasn't made by Tektronix as far as I know, but anyways, anything military, like that scope, or anything like that, they're not made to be serviced. You know, they make it so you cannot repair them. I paid $5 for this, but let me get you on the tripod and show you, because maybe this particular viewer has a meter or had worked on one that was similar to this, but there is no way to zero that meter. Let me get you on a tripod here so you can see what I'm talking about. Alright, one macro here. At least I better be. Okay, Get my glasses. Let's, first of all, let's turn this around here. This meter, the ohm scale is up on top here. It's faded out, a very faint yellow. You can't even read that. It's supposed to be an ohm scale up there, but you'd never know it. You can't read it at all. The meter is supposed to be a deoscillable movement. Either the needle's bent, but it's not sitting on 0. But the meter does respond. But this whole thing is way off. So let's open it up here. And it's very easy to open up. That I will say, it's very, very easy. It's very easy. I've been wanting to make a little video on this. A day like this is not very nice to work outside, so we'll do this. Now, one of my viewers told me, you know, to keep the unauthorized personnel from getting in here, they supposedly hid the mechanical zero adjust, which is usually located right about in this area of the meter, right? I don't know, am I in camera? Yeah. Okay, right about here. Now, the only way you're going to get at that is to take these 3 screws out, but you're not going to be able to do that because, all right, this one's not a problem. You see, it's got a nut there and a oblong washer. But then you've got one here, which you have to take out the circuit board in order to get at it, because you got the nut rolls. I can put my finger in there and turn the screw and I can feel the nut turning. And there's another one right buried way down in the well right in here. So there is no way you're going to get in there. It's hermetically sealed. Keep the dampness out. There's no adjustment on the back. I've never seen a deoscillable movement meter where you would adjust it from the back anyways. But as you can plainly see, the terminals are even shellacked in, waterproof. Okay? What I'm going to do here is I'm going to turn on my power supply, and I'm going to show you what this thing does. I'm going to supply 1.5 volts here because I don't have a C cell. I have a D cell, I have double A's, and trying to get a double A to sit in there, they're about the same length, but it wouldn't stay in there good. So I had to put clips in there and feed it with 1.5 volts. And I put a little wire tie here because I'm pulling on these wires, and the last thing I'd want to do is have the wires pull out from the circuit board. But you can see there's no way you're going to get that out. There's screws, but you got to remove half the component. There's 4 big screws here to hold this in. You have to remove, off camera again, half the components in order to get the board out. I mean, it's not worth it, you know. It's not. It's like I said about the Tektronix. They're not made to be fixed. They are not built to be fixed. So let me get the power supply put in here, and I'll be back. All right. Now we'll get this up to 1.5 volts. This power supply here that I got off of eBay last year, I tell you, is rock solid. I don't believe in building my own power supplies, especially them solid state little things. Buy a commercial one. 1 point. Alright. Let's get this down here. I'm trying to do it at an awkward angle here. Killing my back here. I'm standing up to reach at the thing. I want to be precise. That's close enough. All right, 14.9, 1.491. See if I can crank that up to 1.5. All right, close enough. Close enough for government work. And speaking of that, that's what this is. It was made for the government. All right, so we're getting 1.5 volts right here on the leads, and I don't even know if I'm in camera. I don't even know. So, put the meter away. We got it set. We don't touch the dials because that power supply will not drift. So I trust it with my life. All right, so we're going to feed in. It's a little awkward on the positive terminal. Get my magnifier here. Yeah. It's awkward to get my lead on the positive. I had problems getting it to stay on because the terminal don't stick up on there, and this comes off too, so I may have to tack in a piece of wire or something on that. I don't like pulling on this and end up pulling the wires. Well, if the wires come off of here, I can solder them. That's not a problem. I just don't want them coming out of the meter. So we'll turn it around this way. There, you're not going to be able to see that. You're not going to be able to see that very good. Maybe you will, I don't know. All right. So, all right, I'm not sure how well you're going to be able to see that. You may not see it at all. Let me move it a little bit. These take the regular, the pin jack. So you use a meter probe. It fits nice and tight in there. I'm on the 40 volt. I don't know if you can see that. No, I'm sorry. I'm on the 10 volt. 10 volt. All right. This is the common. It doesn't tell you on the meter face. I had to look all over the internet because there was nothing marked common, not even on the schematic that's inside here. But online, it showed common, so I wrote common over here. So that's the common for all the ranges. So now what I've got here is, I've got two leads, and I'm going to show you now, if you can see the meter. I don't know if you're going to be able to see that with that test lead in the way there. Turn you around this way. I wanted to keep you right side up, but I'm sorry, I have to turn you a little bit on an angle. This is a 9 volt battery, not fresh. It's probably about 8.5 volts. All right, this is the negative, this is the positive. Now we're on the 10 volt scale. Slams over. The needle does not return to 0, but it does work. Okay, that's the 10 volt scale. Now I'm going to move it up to the 40 volt scale. It's up to the 40 volt scale. If you move you down here, you can see. Alright, it pegged it hard on the 10 volt scale. Oh, about 35 volts on the 40 volt scale. So this thing is way off. And we are on DC volts right here. Again, I don't know if I can't tell if I'm on in camera or not. I can't tell. Cannot see that. So I'm just moving you around here. The volts control is on DC volts. I haven't tested AC volts. All I did is test DC volts and ohms. So as you can plainly see, on the 40 volt range, it reads about 35 volts, and it's very hard to read this, and you cannot even read the ohm scale on the top. Alright, so on the 100 volt scale, but I haven't tried that. Let's see what it reads on the 100 volt scale. About half scale, so about 50 volts. About 45. But this don't read to 0. So this thing is way off, way off, and I have no idea. They're all precision resistors in there, and they're all crammed in, so I think this thing is just a, I'll probably, you know, if it didn't cost so much to ship it, I'd give it to somebody. Because it's useless. You can't get into this meter. And I'm going to turn this thing over. I'm not even going to test the resistance. You know, the resistance ranges. Because the needle, you can't even read the resistant ranges up here. It's in a faded yellow. And yellow on white is impossible for me to see. Top scale is the resistance. The ones I've seen online are like a green scale. They're nice and easy to read. So it's faded out, probably from being in the sun or whatever. So I'm going to stop the camera now. I'm going to turn this thing over, take the power off of it, and show you, once again, close examination, that there is no mechanical adjustment unless you take these 3 screws out. And these two, the nuts are going to fall off and you're not going to be able to get them back in. And this also holds the meter in. So let me turn this thing over. I'll get right back to you in 2 shakes of a lamb's tail. Now that didn't take long. Alright. As you can plainly see, there's a nut here, and that's one of the bolts that goes through to the front. Alright, then there's another one buried way down in the groove here, way down. Alright, and let me hold this so it don't fall over. There's another one buried way down here. That, I told you, I put on there as a strain relief because I've been pulling around on these wires, and I don't want it to break off, so I just put that wire tie there. That don't belong with it. Okay, so there is no adjustment. I searched this thing with a magnifying glass and a strong little flashlight, and I searched all over. There is no mechanical adjustment on the meter. So probably what happened, the meter was damaged, and for whatever, over voltage maybe, although the needle didn't appear bent, something happened to the mechanism, and there's no way you can get in there. So if I can jam a screwdriver in here to hold the nut from turning and take the screw out, unsolder these wires, and the whole meter would come out, take the meter apart, and maybe I can reach in there and adjust it, because I'm sure that once this front plate is off here, I'll be able to adjust the deossable movement for center. You know, 0, I'm sorry, 0. But you can't do it in the case. Now, you're not going to drill a hole in here and put a screwdriver in there because you're going to get metal filings inside and that'll destroy the meter and you might as well just hang it up.
Hang it up, Charlie. Sorry, Charlie.
So, this is not a user-friendly thing to work on. Good for parts. I mean, you know, it can probably clip out and drill out these rivets here and save these precision resistors, but I'm not going to do that. There's no way you're going to get that board out of there so that you can get at the nuts, because getting it out is one thing, putting it back in is another story. I had thought about gluing the nuts in place before I took anything out, but I decided not to do that. I would have to use epoxy or something like that. Hot glue, I wouldn't trust it and wouldn't be able to get the thing in there to do a good job, and it's liable to get all over the screw itself and I'll never get it out. So there is no adjustment. So I just wanted to make that point very clear. I'm going to look again with my magnifying glass just to make sure. Sometimes I put my foot in my mouth. No, there is no adjustment, no hole. If there is one, you got to take this board out. It might be on the other side of the meter in the back or on the side, but you got to get this board out in order to do anything, or you got to get the meter out. That cannot be done any other way. So I wanted to show you that. So simply put, this thing weigh about 2 pounds. The meter's shot. Some resistors are way off, maybe burnt out, but it doesn't look burnt. And there's no movement of the deossable. Normally you can just go like this. It's moving, but very, very little, but it won't go to zero. So it could be dragging on the scale, but my vision won't permit me to look that close. So I'm closing this back up, so it's not much good to me. So I'll just get rid of it. I'm not sure if I'm going to make the ham auction or not this year, because my wife has got to have surgery in October, and we're very worried about that. So I may not make the fall ham auction, which is in October, because I'd get rid of it down there along with the big Tektronix oscilloscope, which is under the bench. I'll get you on macro here. This is the model number. So that's it. But as you can plainly see, I'll give you one more look at the display here. You can't even read that. They're faint yellow on the very top scale, very faint yellow. And that's supposed to be the resistance, the ohm scale. So the needle, a meter like this is way too small for me to work with anyways, but it was neat looking, and I thought maybe, you know, it would work. But it doesn't. It needs, well, basically the meter's shot. So that's it. Thanks for watching. More to come whenever I get around to it.